Hey everyone, so I'm doing a video on change of base. Now, change of base is a formula that you can use to help you evaluate logs, graph logs, condense logs, and so on. So the way the formula works is that basically you're going to break the log up into a numerator and denominator, and the base is now going to change to 10 so that you can plug it into your calculator. The A will go to the top, so be parentheses A, and then the B will go to the bottom, so parentheses B. And the new base is 10. We don't have to write 10, it's understood to be there. So basically what the formula is with the A on the top, log A, and then the B on the bottom. And the new base is 10. Okay, so this is really your formula here. So if you would like to evaluate with change of base, sometimes it's easier because you can just type it into your calculator. To evaluate this one, you would say log of 16 over log of 2, and you would get the answer of 4. Okay, now this should make sense. I mean, you can use alpha y equals in your calculator to get it. First off, you do log 16, then do log 4 on the bottom, and you will end up getting the, log 2 on the bottom, and you'll get the answer of 4. Now, just as a refresher, you can do this by hand without using change of base. Change of base is just an option. It might help you in the long run, it might not in certain scenarios. But if I rewrote this problem and I just set it equal to x, you can actually do it another way. The other way you can do it is by changing this to exponential form. This is your base, this is your answer, this is your exponent. So 2 to the x equals 16. You would get the same base of 2. 16 is the same thing as saying 2 to the 4th. So the bases would cancel out, and that's the other way you can get x equals 4. Now the reason why change of base is so useful is for scenarios like this. If you set this equal to x and you replaced it into exponential form, so 4 to the x equals 3.5, you would not be able to get 4 and 3.5 to be the same base. Like, you can't make 3.5 4 to the first, that's not equivalent. So you can't solve it this way. And the reason why change of base is so helpful is because you're able to evaluate something that cannot have the bases become the same, hence the change of base. So what we're going to do is we're going to change the base to 10 by splitting it up using the formula, putting the 3.5 on the top and the log of 4 on the bottom, and you can evaluate using your calculator. So again, alpha y equals, to get your fraction, log of 3.5 over log of 4, and we're going to round to 3 decimal places, so this answer is roughly 0.904. The other thing you can do is condense the logarithm. If you see here, there's 2 separate logarithms, and you can actually reverse the change of base formula by bringing the bottom back as the base and the top back as the inside of the log, and that's how you would bring it back to a single log. The other reason why change of base is very useful is because you can use it to graph in your calculator. So what you would do to graph is you would change this to change of base, and that way you can graph it straight into your calculator. Now, you can either use go to y equals, type this in. You can use alpha y equals if your calculator allows it. Some people, the calculator doesn't allow it, so the other way you can type this in is by doing log of x and then using the division symbol and then log of 2. Okay, so we're going to get an xy table now. I'm just going to do it from I'm going to do negative 1, 0, 1, 2, 3, 4. So I'm going to go to my y equals, I'm going to do log x divided by log 2, or alpha y equals log x on the top and log 2 on the bottom. I'm going to press graph to see what I look like. And I'm going to make my x, y axes on here. So now I'm going to look at my table. Now you should notice that on the table, 0, x equals 0 and negative 1, they have errors there. And that's because the log, on the y-axis, there is an asymptote. There is a vertical asymptote for a log. It's at the equation x equals 0, which is the y-axis. There's your asymptote. Okay, so you can't cross that. So when we plot this and I fill in my table, you want to make sure that you skim past that. 1 is at 1, 0, and then 2 is 1. If you keep scrolling in the table, you'll see that another nice point is at 4, that's 4, 2. Another nice point is 8, 3. So remember, on the Regents you want to plot 3 to 5 points, so usually you want to find points that are pretty exact. So I'm going to plot negative, well, 1 0, 1 0 is here, then 2 1, so 2 up, over 2 up 1, and then 3, 3 there's no point. I mean, you could look at the table and get the 1.5 if you'd like, but the next nice point is 4 2. And then 8 3. 1 2 3 4 5 6 7 8 1 2 3. And I'm going to graph this like that. Okay. If you wanted to go ahead and state the domain and the range of this graph, the domain would be x has to be greater than 0, because you cannot bring this graph over to the negative x's. But the range will go all the way down and it'll go all the way up. So the range is all real numbers. I hope this video helped with change of base, and I'll see you guys soon.